Hello, can you hear me? Hello, hello.
Hello, yes, yes.
Okay, so hope all are you well. So after each vacation, we will start our rest of the class which is not completed. Okay, so basically today is our sixth number of class. So from this class, we will try to discuss about that machine learning using land use land cover classification. How you can easily do using the Google Earth Engine platform for different types of land use land cover classification, and also calculate all of the things we try to complete for the land use land cover classification. Okay, so now we'll start our today's session. So okay, so I simply share my screen. And also start the recorded.
Rama, happy belated.
Yeah,
Rama, happy belated Eid al-Fitr.
yeah, I don't understand.
I mean, happy belated Eid al-Fitr.
Okay, so I also add you on a group so that you can also get contact with us. Okay, okay. Okay, so now can you see my screen? Yeah, so now can you see my screen? Yeah.
Loading.
Okay, so now your video will be okay. Yeah. Okay, so now can you see my screen. Is it visible?
Yeah.
Okay. Okay, so let's go over today's class. So hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis. So basically today is our sixth number of class, and today I also try to discuss about that all of the part for land use land cover classification. How you can easily use the Google Earth Engine platform and connect the machine learning, different types of method of machine learning, and also make the land use land cover classification using the different types of machine learning, and how to make the single class map. Suppose when you want to make only for the water body map or urban body map or crop land map. So this type of class, how you can easily do, we'll start to discuss about that. Then how we can easily calculate the land use land cover classification area for the different class, how much vegetation is available, how much barren land, how much water body, how much build up area is available for your region. This type of calculate how you can easily do, we also try to discuss about that. And how we can easily add the legend, land use land cover classification legend on your map, we also try to discuss about that. And how to calculate the accuracy assessment of your land use land cover classification map using the kappa. Okay, so basically today we'll also try to discuss about that, all of the things we try to complete it. So let's go. So mainly when you want to make the land use land cover classification map using the Google Earth Engine platform, we have to follow some process. And this process is the same for all time when you want to make the land use land cover classification, and also make using the Google Earth Engine platform, and also using the Google Earth Engine platform, you have to follow the same process. So this process is that first of all you have to selecting your ROI. Suppose which region you want to make land use land cover classification map. First of all, you have to import this region boundary shape file on Google Earth Engine platform. Okay. Suppose I want to make the land use land cover classification map for the Dhaka city. So just I simply import the Dhaka city boundary in Google Earth Engine platform. So this is the first step. Second step is you have to choosing and filtering the image collection. Suppose you want to work with Landsat image, then you want to choose the Lancet image. You want to work with the Sentinel image, then you can choose the Sentinel image. After choosing the image, you can follow filtering this image collection. Okay, so you can filter the image collection according to your region, according to the image specific time period, according to the image metadata. You have to filter your image collection. Okay, this is the second step. Third step is that you have to collecting the training point. So in this time, we are applying here the supervised machine learning method. And when you want to apply the supervised machine learning method, you have to take or you have to collect some training point. Suppose you want to classify it for water body, vegetation, build-up area, or barren land, then you have to collect the training point for water body, build-up, barren land, and vegetation. Which class you want to classify, you just simply take their training point. After, you need to merge all of the training point together. So all of the training point you will merge and make a one class. Okay, so all of the training point you merge and make a one class. And after that, you need to extract the pixel value. So you want to collect the training point for water, you want to collect the training point for the vegetation, you want to collect the training point for the barren land. So all of the classes training point, you have to collect some pixel value of band. And this pixel value of bands is creating the data set. Okay, and this data set we need to divide into two parts. Some data we use for train our model, and some data we also use for test our model. So if you have, you can also use here the 70% data for train your model and 30% data for test your model. Or if you have, you can also use here the 80% data for train your model and 20% data for check your accuracy. So in this time, we can divide the data set into two parts. After that, we create the classifier and classify the image. So basically, classifier, it's an machine learning method. In this classifier, if you want, you can use here the random forest. If you want, you can also use here the classification and regression trees. If you want, you can also use here the support vector machine. So there are a lot of classifier is already available in Google Earth Engine platform. This classifier you are used and then classify the image. And then create the classified image, then display the result. After that, you want to check what is the accuracy of your map. For that, we need to create the confusion matrix. From the confusion matrix, we can check our accuracy. And then you can calculate the area of our each classes, how much area is available for the water, how much area is available for the build-up, how much area is available for the vegetation. So this type of calculation you can also take in here. So basically, this is the process when you want to make any types of land use land cover classification map. Suppose you want to make the cropland classification, you want to make the normal classification, land use land cover classification map. So when you want to apply any classification using the supervised machine learning, you just follow the same process. You have to choose, you have to select your region first. Which region you want to make the land use land cover classification, just import this shapefile. Then you have to choosing and filtering. You have to choosing and filtering the image collection and collecting the training point from the satellite images. Okay. After that, we have to merge all of those training points together, then make a training data set. Mainly this training data set stored all of those training points band pixel value. Okay. Then this data set, you have to divide it into two parts. Some data set, suppose 80% data set we are using for train our model, and 20% data set we are using for test our model. Okay, and 80% data set you want to apply the classifier. Suppose in this time we are applying the random forest or classification trees for classify the result and create the classified image, then display the result accuracy assessment, we are applying here the confusion matrix, and finally we can calculate it the area for each classes. Okay, so basically this is the process when you want to apply any types of land use land cover classification map. So it also better, I'll also try to show you all of the things practically, then you can easily understand about that. So let's go. So just I simply open my new code editor in a browser and apply all of the process step by step. So it opened my code editor in here. So in this time, first of all, I have to import the boundary shape file. Okay, which area you want to make land use land cover classification map, you can simply import this boundary area. Okay, so I simply click on the asset tab, get loaded. Okay, so I simply find out my boundary which area I want to classify. Suppose I want to work with for a city of Dhaka. So I want to work with for the suppose Dhaka city. Suppose this is my shape file. This area I want to make the land use land cover classification map. So first of all, I need to import this boundary area of Dhaka city. So this is my region. So this region class. So I simply import. So now imported it's in here, you can see imported. I give a default variable name. Suppose I use it, suppose RY. Okay, you can use any name. Then I have to display the result of the layer of this map.add layer function and add this object is that RY, and also center focus. So use at the map.center object and use at the ROI. Suppose put at the suppose 10 and click to the run. So first of all, this is my first step. I selecting my region. So this is my boundary. For this boundary, I want to classify the land use land cover classification map. Okay, so this is the first step. Second step is that we have to choose. So in this second step, you have to choosing and filtering satellite imagery. If you want, you can use here the Lancet, or if you want, you can also use here the Sentinel. So both of images are the same process. Okay, so in this time I simply go to the browse data catalog and find out the data set. Suppose in this time I want to work with for Lancet image, but you can also apply the same process for Sentinel imagery also, because this process is the same, both of satellite images. So simply click on the Lancet. So I simply go to Lancet. So here I can get all of the Lancet image collection. Suppose I want to work for the Lancet 8. So simply click on the Lancet 8 image collection. So here I can get all of the Lancet image collection. You can see Lancet 8, surface reflectance, top of atmospheric, raw image. So I want to work with the surface reflectance. Okay, so basically when you want to make the land use land cover classification map, then it also better to use the surface reflectance satellite imagery. Okay, so because this is a surface reflectance, and when you want to make the land use land cover classification map, So mainly it's identify different types of feature on the surface. So that's why it also better to use for the surface reflectance. Okay, so just I simply click on the surface reflectance. So now I can got all of the information about the Landsat 8 surface reflectance satellite imagery. So here I can see this imagery is that dataset availability date is that from year of 2013 0380 to 2023 0414. So this time period we can access this dataset, and also you can see they are mentioned the time. So it also updating daily, okay, according to this time. So in this time, this dataset provided is that USGS and Earth in the snippet. Basically, this is the unique ID of the dataset. So I can simply copy this unique ID from here and then paste in my code editor. So just I simply paste, okay, and take a variable name. Suppose this variable name is that L8, okay. So in this time I choose my image collection, okay, Landsat 8 surface reflectance I choose. Now this image collection I need to filter. So now I need to filter this image collection. So for filtering, so mainly filtering, we can filtering three factor such as where, then how, and when. Okay, so where, how, and when. Three question. According to these three question, we filtered this image collection. Okay, so let's go. So just I simply take a variable name. Suppose this variable name is that image. And first of all, I call my full image collection. This is the image collection, full image collection, and its storage variable name is L8. So I simply copy the L8 and paste here. Now, first of all, where I want to filter, where I want to filter in Dhaka city. So put here the filter bounds, and then put here this ROI, because ROI is stored my variable name. Then how? I want to get only for this image, which image will be not more than 1% cloud cover. So I say cloud cover. So basically this is the image properties name, and put here the less than, and put here the suppose less than 1. Okay. Then when is mainly a specific time period. Which time period you want to get these satellite images. So put here the filter date function. And here I can get started and end date. So put here the suppose 2020. Suppose 1st January from 2020 December 31. Okay. Okay. So now I can see I filter my image collection. Here, this is the Dhaka city region. Then how I want to rate only for those images, which image is the less than 1% cloud cover. And when, this is the time period. So basically, when you want to filter any satellite images, we just follow this process: where, how, and when. Okay, where for filter bounds, how for filter metadata, and when for filter date. Okay, so in this step here I can get, suppose you want to check, suppose I want to print this image and use the size function. So now it determine how many images I want to got in here for this, according to this condition, how many satellite images I want to got. We can get the result in here. I can get only for the 5 images. Okay, for this condition, 5 images. And if you want to check the specific image time period, suppose you want to simply print this image and check, I can get all of the image acquisition time. You can see, simply click on here and go to the feature. So here I can see the first image is the year of 2020, 11th February, 26th January, 11th February, 30 March, 27 December. So I can get all of the image acquisition time period, and each image total 19 bands. Okay, so when you want to work with a single image, suppose in this time, if you want, you can create the median composite. Suppose from total 5 images, I want to create the median composite, and then make the land use land cover classification map. Or if you want to work with only for the single image. Suppose you want to work for this image, simply click on here and copy this ID, and you can only work for this image, which image capture is the year of 2020, 11th February. Same process. Okay, suppose you want to work with for this image, so simply take a variable. Suppose I put the variable img and use at the image and paste at this id. Okay, so now you want to display this image. Suppose you can simply use at the map.add layer function and display this image and click to the run. So now you can get only for this single time period image, single time period image. So you can see this image now loaded. This image acquisition time is that year of 2020, 11th February. If you want, you can simply use at the clip function and then use at the RY and click to the run. So it clip with my boundary area. You can see it will be loaded. Okay, this area I want to got this image, and this image acquisition time is that year of 2020, 11th February. If you want, you can also add here the color plated. Suppose you can simply add here the, you can see surface reflectance band 4, surface reflectance band 3, red, green, and blue, and also stress 98% for better looking, and apply. So now you can see we can get the image look like this. And this image, what is the time period about this image? Image is for year of 2020, 11th February. I can got this image, single time period image. So you can see, if you want, you can also apply the single period time period image, or if you want, you can also create the median composite. In this time, I want to get total 5 images. I want to create the median composite using all of those images and work with this satellite image. Same process. Okay. So I also try to show this part. So this is the single image when you want to work. Okay. So in this time, I want to work for median composite and make the land use land proper classification map. So for that, I can simply use the median function. So for that, I can simply use the median function. You can see I simply use the median function and then clip with my shapefile. Simply use this clip with my boundary ROI. Okay, now display the result. So just simply use the map.add layer function and call the image and try to display the result. So now we display the result, total 5 images, median composite. So here I can get, so I want to show the display the result. So simply click on here. And now add here, suppose B4, B3, and B2. Also increase the stretch 98%. And then simply apply. And also import this. And then simply copy this visualization parameter, variable name, and paste the object name. After object name, I can simply paste this visualization. So now you can see what happened. In this time, I filter my image collection for my region of interest, then image specific metadata and image specific time period. So this is the second step when you want to apply. So filtering. So in this time, the second step is that we can simply choose our image collection Landsat 8. After that, we can simply filtering this image collection. Okay. So this is the second step. If you want, you can also work with for the single image using the same process. But in this time, I want to apply here the median composite and then clip with my shapefile. So now this image, which I want to display on my map, it showing the median composite, and this median composite is created from the total 5 images. Okay, so this is our second step. In this time, you can see our slide. Our third step is that we need to collect some training point. Okay, so we can collect the some training point. Suppose you want to classify the water body, so you can take the training point for water body. You collect the training point for vegetation. So you can collect the training point for the vegetation. You want to collect the training point for the barren land. You can collect the training point for the build-up area. So all of the training point I need to collect. So for that, we can try to show you this part. So we can simply take this training point. Okay, so in the third step is that you can see, I simply write the pro step. Third step is that you need to collect training points for classes. Okay, so in this time, how we can take the training point? So for the training point, we can easily take from the satellite images because it is a totally supervised machine learning. So that's why we need to collect the some training point for specific classes. Okay, so let's go about the training point. So in this time, I want to take the training point. Suppose water body. Okay, so for that, I can simply click on, you can see marker, click on this add a marker, and new geometry will be added in here. I simply click on here and put the name. It's a, you can use any name. So I collect the training point for water. So I simply put here the water. Okay, then go to the feature collection, import as feature collection, and property, set the property, suppose class, and set the value for 0. Okay, so this property name all time will be class. When you want to take the training point for urban, you can use here the class. When you want to take the training point for the build up area or barren land vegetation, so all time it will be class, and value it will be start from the 0, then 1, then 2, then 3. Okay, so let's go. Simply click on the OK. So now you can see I can identify about this is the water body in here. So I just simply take the training point for the water body from here. So you can see simply click on here, then it will be bold color. After selecting the bold color, then simply take the training point water body. So I simply take this training point for water body. And we are using here the different types of band combination for identify different types of feature. So in this time, you can see I want to use here the band combination is that red, green, and blue band. Okay, if you want, you can also use here the near infrared, then red and blue band. Then you can see what type of result you can got. You can see. Simply click the apply. In this time, you can see when you want to apply this band combination, in this time, water body look like as a black color. And vegetation or dense vegetation showing as a red color. Okay, better red color. And water body showing as a black color. This type of water body, black color. Okay, suppose you want to apply this band combination such as B6, then B4, and B3, and also okay, apply. So now I can see, now I can get the result look like this. Okay, so it's not okay. So you can easily get all of the information from the link. So I also, you can simply search here Landsat 8 band combination. So different types of band combination. From different types of band combination, you can easily identify different types of feature easily. So here you can see, you can also simply go to this link, then you can easily, this is the link, then you can get the all of the things easily about the band combination of the Landsat 8, and you can also apply this same information in Sentinel-2 satellite imagery. Just simply change the band. Okay, so here you can see okay, suppose you can see this is the band combination for the 432 red, green, and blue. Then I can get the result look like this about the color, and mainly it is the what human eyes can see. Healthy vegetation is the green, unhealthy flora is the brown, urban feature appear the white and gray, and water is the dark blue or black when you want to apply this band combination. Okay, also you can see color infrared 543. So when you want to apply this band combination, you can easily identify the red color. Red have a better vegetation. Okay, red color, it's identify the better vegetation, and dark areas are water and urban areas are white color. So when you want to apply this band combination, also you can see short wave infrared. When you want to apply this, then it will be showing as a green, indicate the denser vegetation. Vegetation has a lighter shade, and urban areas are the blue, and soil have the various shades of the brown color. Okay. Also, you can see this is the band combination for the agriculture 652. So when you want to apply this band combination, then we can easily identify the cropland. You can see this type of a square, or then we can get the cropland. Also, we can this type of the barren land. Okay, we can easily identify, and the water bodies look like this blue color when you want to apply this band combination 652. Also, you can see when to identify the geology 768 this band combination. Okay, so we are using here the different types of band combination for identify the different types of feature. And when you can see in this time, I can easily identify this is the water body, so I can simply take this staining point for the water body. So different types of band combination identify the different types of feature. I also take that water body, suppose, yeah. So you can see water body. We can take the training point for the water body, and we are applying the different types of band combination for taking the training point. Okay, so different types of band combination, we can easily identify the different types of feature. Okay, so that's how you can using here this. Okay, so in this time, suppose I want to apply this band combination such as, okay, so this is the 5. So I want to apply, suppose you can say I want to apply this band combination. Yeah, 652. So then you can simply put here the 6 5 and also put here the 2. Then apply. So now we can easily identify the vegetation. Okay, look like this vegetation. This is the vegetation. Okay, and also you can see this is the brown color. It's a barren land. Okay, so now we are using this band combination and take the training point for the vegetation and also take the training point for the barren land. So let's go. So for that, simply click on here and then click on the property. So put this name such as, suppose I want to take the training point for the vegetation, and then simply click on here and click on the feature collection and set the property. Property name will be same. Put here the class and set the value for 0 1. Okay, put the 1, then okay. This vegetation, and after take this training point. And if you want, you can also more classified. Suppose you want to type the vegetation such as crop vegetation or cropland, or if you want, you can also forest. Okay, so we can easily identify. But in this time, all types of vegetation, I including in the vegetation, all types of crop, then forest, and take this training point. Point for the barren land. So simply click on the new layer and click on here and take this, simply click on here and take this, suppose bare land, and then geometry feature collection property name will be same for class, and set the value for 0 1 and then 2, then okay. So then I can simply take the training point for the barren land. This type of brown color is identified as the barren land. Okay, suppose I will take the training point for the build up area. So simply click on here and then simply click on here again and put this as build up and import as feature collection, and property name will be same for class, and set the value for 0 1 2 3. Okay, then put here the one. And now I want to use here the suppose true color composite. So simply click on here, suppose, then put here this B4, B3, and B2, red, green, and blue color, 98%, and apply. So I can simply take this training point. So this type of is the build up. Okay, so I take the training point for the build up. Okay, so basically this is the process how you can easily take the training point. So now anyone any question? Okay, guys, check the mass question. Yeah, it also possible when you want to identify the grass and trees. It also possible, but then it also possible then you can take the training point from the ground. So you can take the training point. Suppose mainly when you want to make the crop classification map, then we have need to import the ground truth data. You can simply go to the field and take the training point, such as this is the crop plant, this is the crop plant. So you can take the some training point as a GPS location. Okay, in Google Earth Engine platform, we are easily imported the GPS location, specific coordinate, latitude and longitude, and then we are imported this latitude and longitude as a point. And from this, we can take the all of this point we get using as a training point, which we can take from the ground. Okay, then we are applying this, and also we classified the grass, then vegetation. So basically in this time, when you want to make the this type of cropland, this type of specific trees, specific vegetation, you need to classify. Then it also better you want to import the ground truth data and also take the training point. Okay, so otherwise it also mixing, suppose grass and vegetation or crop, this type of pixel value almost same. So in this time, when you want to without training ground truth data, when you want to take the pixel value, we can get all of the things will be same, almost same, and there is a chance to mixing. We as suppose grass and vegetation or grass or cropland will be mixed to each other, and then we did not get the proper classified result. Okay, so in this time, this is our third number step. We can take the training point for water body, then vegetation, then barrel and build up area. So in this time, we need to merge all of the training point. We need to merge all of the training point together. So for that, we need to merge. This is our fourth step. Merge. So take a variable. Suppose this variable name is that samples. I can put the variable name of samples, and then merge all of this training point together. So water, it also merge with vegetation. It also merge with airland. Then it also merge with build up. Okay, so I simply merge all of those training point and store it in this variable samples. So now simply print this result, simply print these samples and click the run. So now I can get all of the information about this training point, how much training point I have to got, all of the things we can get in here. Okay, so now you can see here where you can get total 190 training point for all of those classes. For water, vegetation, barrier, and build up, we can take total 190 training point. And you can see here already get the class. Suppose training point number 1, what is the class? Simply click on here and you can see the class is the 0. Okay, and also you can see, suppose I want to check about the 44, what is the class? You can check the class is that 1. Class 1 means that this training point I take for vegetation. You can see because I want to use here the 1 value for the 1. Also you can see, suppose all of this training point including with their class. So here you can see this 38 is the class for the 1. So this 70 this training point I want to use for 1. What is the 1? 1 is for vegetation. And what is the specific? We can also get their longitude and latitude about this point. Okay, so here you can see all of those training point is include with their specific class. Okay, and it is a totally supervised machine learning method, so that's why we also need to pre-catalog data. So this is our pre-catalog data. So in this time I want to take the training point. This training point, in this time all of those training point I want to extract the band pixel value. Okay, so from this training point, all of this training point I want to extract the band pixel value, and then band pixel value it's a data set. Okay, this data set we want to use for train our model and also test our model. So in this time we need to create the data set. Mainly data set is that band pixel value. Suppose every single point, you can see every single point I want to extract the band pixel value. So suppose for this point I want to extract all of the band value. Okay, so for this point I want to extract all of the band value. For this point I want to extract all of the band value. For every single point we extract all of the band value, and this band value is our training data set. This training data set we are using for train our model and also using for test our model. Okay, so let's go about that. So for that I simply, first of all I need to select which band pixel I want to extract, which band. So first of all need to select bands, which band I want to use for extracting the band values. So take a variable, suppose bands, and then make a list which band you want to use. So basically in this time you can see this Landsat 8 image collection. I simply go to this image information sheet. So I simply open that, simply copy, paste it. Okay, so this is the image collection. Here you can see, here I can get all of the band. You can see SRB1, SRB2, blue reflectance band, SRB3, SRB5. Okay, so SRB6, SRB7.
Good morning. Good evening. How are you?
Yeah, I am fine. Can you hear me? Okay, any question or any? Okay, I think it's outside sound. Okay. Okay, so now you can see here, from this we need to select some band, and this band we need to select and then extract the band pixel value. So let's go about that. We can simply select this band, such as I can simply make a list and put here, suppose SRB1, then also put here the SRB2, SRB3. Basically this is surface reflectance, so that's why I need to use that the SRB4, SRB5, SRB6, SRB7, also short wave infrared 2. So put here the SRB7. Okay, so in this time here I can use all of those band and extract the band pixel value for every single point. Suppose this point, what is the value for all of those band? So for this point, what is the value for all of those band? Okay, I want to extract the band pixel value. So for that, I can simply take a variable. So I put commenting, suppose extracting the band pixel values for each points. So I also send you the code. So then when you want to the code, you can easily also get all of the comment, and then you can easily idea about this line of the code, what I want to do in here. So take a variable. Suppose this variable name is that training. Okay. And then I want to extract the band pixel from this image. Okay. From this image, I want to extract the band pixel value. And this image is stored in a variable. What is the variable name? You can see this variable name is the image. Okay. Because this image is mainly stored in this variable. When I want to map.add layer, then call the object, then it's display. Okay. So I simply copy and paste in here training. Then from this image, so basically this image has including total 19 bands. You can see total 19 bands is available in this image, but from this image I want to select only for those band. So simply copy the bands and paste here. Okay, and then use a function sample regions.